In this presentation, we're going to look at the Poisson probability distribution, and we're going to look at a worked example with using statistical tables. So this is the question here. Consider a Poisson random process where a random variable x is the number of occurrences per unit period. Okay, so x is the number of occurrences per unit period. That's very general here, but you can have that can mean many things. Now, for this process, the Poisson mean is going to be m equals 16 occurrences per hour. Okay. By the way, just as a remark, with the statistical tables I'm using, the Poisson mean is denoted m, but in other books it might be denoted lambda. Okay. So this is a quick example of what we're going to do. I'll just get into more detail here. So what we have to do is determine the probability of more than 20 occurrences in 1 hour, precisely 10 occurrences in a half-hour period, and no more than 15 occurrences in a 45-minute period. So the probability of x greater than or equal to 20, probability of x equal to 10, and the probability of x less than or equal to 15. Okay, now the wording there is very important. So importantly, the Poisson mean m is for a specified time period. So if the time period changes, then the Poisson mean must change accordingly. So we're going to look at the first one here, the probability of x greater than or equal to 20. And so what I'm going to do first off, m is, that's the answer there, but how do I get it? M is equal to 16. That's the first important thing I have to consider. So I've opened the Murdoch-Barnes statistical tables, and I've gone to the cumulative Poisson probabilities and table 2. What I'm going to do is I have to go down to 16, so I have to flick through all the pages here. I'm just going to speed it up. So this is me looking through all the pages, and I have to find where it's m is equal to 16. So there we have it there, and it's on the left hand side. So I'll just scroll back up there. So it's on the left hand side there. So what does this mean? 4. That means 4 or more occurrences in an hour. The probability of that is 0.99. Here we have the probability of 10 or more occurrences, 0.9567. So it's whatever this value is or more. 10 or more, 11 or more, 12 or more, that's the probability. Now what are we looking for again? If I actually forgotten the question here, just bear with me a second. 20 or more, so we're looking for the probability of 20 or more. So we go around here, and the probability of 20 or more is 0.1878. So that's 20, the probability of 20, 21, 22, 23, 24, and so on. So the probability of 20 or more is 0.1878. So that's the first question. Let's go to the next question here, and that is we have asked to find the probability of x is equal to 10. Okay. Sorry, let's go back here a second. Precisely 10 occurrences in one half hour period. Well, first off, if we expect 16 in 1 hour, we only expect 8 in half an hour. So first thing we do there is that, so if m is equal to 16 per hour, then for a 30-minute period, m is going to be 8. So the Poisson mean for a half-hour period is 8. The second thing is we're asked to find the probability of exactly 10. Now the way this table works is 10 or more, 11 or more, 12 or more. That's the way it will be given. So to find out the probability of x equal to 10, we find out the probability of x of 10 or more, and then find out the probability of x, being 11 or more. And the difference between the two is simply the probability of x is equal to 10. Now, here's the answers here, 0.2834 and 0.1841. But let's just go back to the tables there and have a good look at that, how we got them there again. So first off, we have to go back to where m is equal to 8. Now, so I'll just scroll back up here. So that's the first thing. We go to m is equal to 8. And we go to 10 or more, 0.2834 and 0.1841. The difference between the two is the probability of x being exactly equal to 10. And as I just put it on the slide there, the answer is 0.0993, just slightly short of 10% probability. Okay. the next one is the next question is if what is the probability of 15 or less, no more than 15. Let's go back here a second. No more than 15 occurrences in a 45-minute period. So x can be 15. We could have 15 occurrences, but no more than that. So it's x equals 0, x equals 1, x equals 2, all the way up to x equals 15. Okay. So what we're going to do is use the complement rule for that. I'm just going to scroll back up here. And the complement rule of the complement of x less than or equal to 15 is the complement of that is x greater than or equal to 16. Just remember the Poisson distribution is a discrete probability distribution. It is not a continuous distribution, so that is why we have the complement of x less than or equal to 15 is the complement of that is x greater than or equal to 16. So if we look at the tables, we'll find that the probability of x greater than or equal to 16 is 0.1556, and just subtract from that. Now again, for a 45-minute period, we have to change the Poisson mean to suit a 45-minute period, and the Poisson mean is therefore going to be 12. So let's go back to the tables now. Let's just go through the tables here. So I'm going to scroll down here. I was at m is equal to 8, and I'm just going to scroll down here to m is equal to 12. And we're going to go down to where m is equal to 16. There it is there, 0.1556, and the complement of that is the probability of 15 or less. So that ends our presentation about how to use the statistical tables for probability distributions. And I'm going to wrap it up there when I've figured out how to switch this off. There we go.